So one of the big things we've been working on in the last 6 months or so is to bring our Android tablet app up to par with our iPad tablet app. So when I started Square, we just had the mobile app, and it was super simple, right? You would just enter a price, and you would swipe your credit card, and then you could charge money to people. The iPad came out, so we rushed to implement an iPad application, and it wasn't all that much more sophisticated. It did have a basic item library, but over the years, the iPad app has become remarkably more complicated, right? We've added categories and discounts and conditional taxes and partial refunds and all these things that allow merchants to run a bigger and bigger business on our products. So Pierre here, PY, as he's known, is on our register team, and his big project over the last several months has been to bring parity to Android tablets. So all that fancy stuff that larger merchants use on iPads is now becoming available on Android tablets. And what Pierre discovered is when you bring the UI to a tablet and you bring it to more modern phones and you have higher pixel density, when you get to certain steps in the payment flow, such as the signature, and you're signing and creating a gigantic bitmap, you run into out-of-memory errors, and the app crashes. So our app was crashing too often. So in typical Square style, Pierre wrote this awesome open source library called Leak Canary, and he's going to talk all about Leak Canary and how it works and how it found all these memory leaks, not only in Square's applications, but he's open sourced it, so it's finding memory leaks in all of your applications, and it's finding memory leaks in Android. So take it away, PY.
Jake told me about that, but I forgot. So hi, I'm PY, and today I'm going to talk about Leak Canary. So, like you said, it's an open source library. Let's start with a simple question. Who here has ever had an out-of-memory error before? Right, everybody. Okay. So, you know, our phones have a limited amount of memory, and it's really hard to deal with that. And when an application runs out of memory, obviously it crashes. For us, this is the signature screen. This is where, you know, the customer is paying and the app is crashing. It's the worst. Like, did I pay or not? Am I getting the money or not? It's very important to fix that. So to explain all of these concepts, I'm going to talk you through a metaphor. So my hand. My hand represent the amount of memory that you can hold in your application. And so in my hand, I have a set of keys and an Android collectible. And you'll notice that this Android collectible is holding on to two readers. There's a small thread here. So I'm using it, and when I'm done, what I do is I just throw it on the floor, and the garbage collector, my Roomba, just collects it, right? That's how Java works, right? So, I mean, that's great. The problem with that is sometimes I think, you know, I'm done with this thing, I'm just throwing it on the floor, and, well, sometimes something else is holding on to it. Here, my keys are like somehow tangled into this Android collectible, and I can garbage collect it. It's not on the floor anymore. And I mean, we all make these sort of mistakes, and it's very hard to know when we're doing this sort of mistake, and the garbage collector can fix it. So this right here is a memory leak, and when these memory leaks accumulate, your hand is like holding on all of these things, and at some point it's too heavy and you just crash. Yeah. So introducing Leak Canary. In very simple fashion, what it is, so we have this Android collectible, and we know we're about to like just throw it on the floor. We attach a little pin to it. I'll get to the details later, don't worry, like it's going to be actually going to be a technical talk. But for now, let's say we attach a little pin to it, and it's a smart pin, and what it knows is it knows when it's in the garbage collector. So, you know, it's like, oh, I'm in the dirt now, I'm good, I've been garbage collected. And if it hasn't been garbage collected, then that's when maybe there is a memory leak. So what it does is it takes a photograph of the memory, And then it's going to analyze it and give you the result in form of a chain of references that are preventing garbage collection of that object. And as soon as we see the result, we can identify where the problem is and we can fix it. All right, let's actually get technical. Let's come back to our screenshot. So this is a crash, right? And it's very sad. And if you look at the stack trace, what you get is out of memory. Hello. Okay, good. Out of memory error. So if you can see the stack trace, it's very simple, right? We're like, okay, I want to sign on the screen, so we're going to use a huge bitmap on which we're going to draw the signature. And it's going to be the size of the screen, and try to create a bitmap, and bitmap is too big. So what do we do? Well, we're all smart, and we realize, oh wait, I'm allocated a bitmap, ARGB bitmap, but I'm only drawing my signature in black and white, right? So maybe I can change the channel to only use 1 byte per pixel instead of 4, right? That's going to optimize the amount of memory you use, and it's going to improve the problem, right? Maybe we can do even better and even dirtier. Let's see. What if, when I try to create a bitmap, I catch out-of-memory error, and then and then I clear all my caches, and then I try to run the garbage collector, and the Java code says maybe it's gonna run, maybe not. We don't know it actually runs, sort of, most of the time. And then I'm gonna sleep and then try a bunch of times, and after a few times, maybe okay, I'm gonna just crash because I don't know what to do, right? Well, the inspiration comes from the Android keyboard, and so Latin IME, which is the default Android keyboard, has this. Used to, at least 2 years ago, I don't know if it's still the case, that when they were trying to inflate the view hierarchy for the keyboard, they would just try a few times just in case. And sometimes sense, right? So let's look at what the problem actually is here. So we have a heap. The heap is almost full. We're trying to allocate a big bitmap, and it doesn't fit, right? So we think that we should make a smaller bitmap. The real problem is that the heap is full. That's, coming back to that image, it's the hen that's about to crash on the floor. And all these little leaks, they add up. And so if you make the bitmap smaller, all you're doing is delaying the problem, and it's going to happen eventually. So a very simple example of memory leak, you all know it's bad, right? A static field holding a view. So you could say a view, it's a tiny thing. My view is just, a text view, just doesn't have much memory, right? So it doesn't sound like, okay, it's bad, I'm keeping this field and I'm never clearing it, but it's not bad. Well, it turns out a view has a getParent method. A view is able to give you its parent, right? So it has a reference to its parent. So as long as the view is not garbage collected, the parent is not garbage collected. The parent has a reference to its parent, etc., etc., etc. But the parents, the view groups, also have references to all of their children. So if you're leaking a view, you're leaking the entire view hierarchy. Also views, they reference the context, so you're leaking the entire activity. A few megabytes, right, for just one view. And of course, all the views that use bitmaps are referencing their bitmaps, and so all of this is basically leaked. So the static field here is called a GC root. So what we call a GC root is basically something that's never going to be garbage collected because it's part of the I guess the VM. Bad at explaining this. So static fields. Think about local variables in threads. Everything that is not just hold on to it. If there's nothing else holding on to it, but it's still not going to be garbage collected, then that's a GC root, and that's what causes all of your memory problems. All right, so we know we've got a memory leak. It crashes. What do? We take a photo, a heap dump, and the heap dump, it's actually very simple. It's like you take all the memory and you put it on the file system. So it's a file that contains all of the classes, all of their memory address, all of their memory addresses. Yep, maybe. I'm going to mute that one. Yeah. All right. Let's see if that's better. So it contains all of the memory addresses, all of the instances, everything you need. But it's a very low level, it's a binary file that you won't ever be able to read. You don't want to do that yourself. That's horrible. But there's something called Memory Analyzer. And Memory Analyzer, it's an Eclipse project that reads this thing and builds a model in memory, and then you can actually analyze and navigate around the memory, and that's really nice. So for example, we could find that view, we could like look for all the views that are detached from the window, and then if they're not, if they haven't been garbage collected, then there's probably a problem. So let's come back to our Android collectible. We find in Math that it's been leaking, so what do? We try to find the chain of references that is tying it to the keys. And if you think about that, so you have an object, it's referencing another object, right? And that other object is referencing other objects, etc., etc., etc. So this is a graph. It's actually a direct graph. It flows one way. And what's very interesting about that is you can apply all the, if you've passed interviews in the Silicon Valley, you know everything about graphs, right? So you can apply a bunch of algorithms to, for example, work the graph back. So usually, when you're at runtime, you have access to object, you can go down the graph. I can see what my object is holding on to, but I cannot see what is holding on to my object. But if you're after the fact, and you're parsing that graph, you can actually build, you can walk backwards, and you're able to find what's referencing your object. And so that's what Math is doing. And there's something called the path to GC root. So I told you about the GC root, right, like a static field. And so it can find all the references, the chain of references that's holding your object in memory from this static field to some other object that's leaking. And then here we're using the shortest path to GC root. Interesting. So all of these passes are valid, but if you want to find the one problem, it's easier if there's less noise. So you just need to, the shortest path is going to be the one that's the easiest to look at. All right, I know Eclipse is pretty hard to use and watch. Like it looks really bad. Anyway, once you get there, this is what a shortest path look like, and this is very tiny, so it's going to be hard to read. But once you have a little bit of experience, you can see, okay, I have an activity leaking. I have a view leaking that has a context as this activity. Okay, there's an object that's actually holding a reference to that view. And then blah, 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 dagger, BS, BS, BS. But you can see like singleton binding, so you're like, oh, okay, this thing is the singleton. And then you're like, oh, scope. Oh, this is like the application scope. All right, so I have a singleton in my application scope that's holding onto a view. That is my problem. I have something that's living in the application class, but it has a reference to a view. That is bad, and that's what I can fix. Right, so that's all nice, We still have to take a heap dump and analyzing in Math, right? But when the app crashes in production and the customer is like not able to take a payment, are you gonna take a heap dump, upload it to the web, and just 70 megs, nobody's gonna hate you. I mean, Facebook might do that, but okay. Let's try to detect it earlier as soon as it happens. So that's what Leak Canary does. Find the object when it should be garbage collected. And so the idea is many of your Java objects actually have an explicit lifecycle. Think of an activity, onCreate, onDestroy, right? After it's been destroyed, you expect it to be garbage collected at some point. A request would be the same. So an activity is a perfect candidate for these sort of things where you know that it's going to be created and garbage collected, and when created and destroyed and then garbage collected. So when it's been destroyed, you expect it to be garbage collected. If it's not garbage collected, then you have a problem. Right. So coming back to this Android collectible, when the lifecycle ends, when the activity has been destroyed, we need to look at it, keep a reference to it, and say, okay, I want to check in like 5 seconds, are you garbage collected or not? And then if you're not, maybe we have a problem. Maybe not. Maybe it's just like the GC is being lazy. But we should check. So the way this works is, in Leak Canary, we created an object called refWatcher, and so that's how you set it up. It doesn't really matter. But what's interesting about it is, you can then say, hey, watch this object. So watching means it should be garbage collected soon. So here, you probably know that there's something called activity lifecycle callbacks that you can set on your application. So before ICS, you had to, I think it's ICS, you had to, like you didn't have a one point where you could set a listener for all activities, and you had to like do that in all of your, like a base class of your activities, but now you can, and so on the application object you can register the activity lifecycle callback. And then, so here what we do is when the activity has been destroyed, we say, okay, it's going to be garbage collected soon, so let's watch this guy. Which, to explain how we watch things, I need to introduce you to the concept of weak reference, and that's hard. Who knows what a weak reference is? Right? A lot of people. I'm still going to give like a very short explanation. The idea is in your VM you have strong references and weaker references. So like your normal objects have strong references to other objects. And a weak reference is basically a reference that stays there until all other strong references are cleared. So this is perfect for a cache. You have a bitmap, you use that bitmap, you put it in a cache, so every time you want to use it, you ask that cache for it. But if you use weak references in your cache, then eventually if nobody has a reference to that bitmap and it hasn't been used, the GC is going to come and like claim it, and the weak reference is going to be cleared. And that's great for us, because that's a way to know if something has been garbage collected or not. If it hasn't been garbage collected, maybe there's a leak, maybe not. So that's what we do. We watch the object, we create a weak reference to it, and then later on, in an executor, we ensure that it's gone. And then we take a photo. We trigger a GC. This is like another one of those hacks. We shouldn't, but like just in case, we trigger a GC and it might not do anything. But if it does something, then maybe it's going to clear the object. But if it doesn't, then we trigger a heap dump. And then, so we have a heap dump. What do we do with it? Well, we could do the same thing, right? We open it in Mat, we try to like click around. And I was doing that for a while. I was like, right, initially I wrote something that would upload things to, upload all these heap dumps to like a Slack channel. And I would like manually download them and then open them, and I would spend, I don't know, 5 minutes per file, and it's just horrible. And I realized I was doing the same thing over and over and over again. And at some point I had a haha moment where I was like, wait, Eclipse has plugins. I could write a plugin to do all that clicking for me, and it would just like, I'm always doing the same thing, I could have a plugin that does that. But who likes to write Eclipse plugins, really? Not me. So instead, I looked around and I found a project that basically forked Eclipse Memory Analyzer and removed the UI. And that was 4 years ago. Someone did that 4 years ago. It's actually the founder of Zero Turnaround, I think. Anyway, he did that and put that on the Git repository. And then 2 years later, another guy took that and forked it and added support for Android heap dumps. And so I looked at that and I was like, that's great. It looks like what I want. So, and then I created Haha, which is LS Android Heap Analyzer. And so the thing with that is I didn't write any code in there. It's basically I just reused that for cleaned a few things and then just made it available in Maven because nobody did that before. The great thing is, so it supports Android heap dumps and it runs on Android because that's just like basic Java, no special APIs. The problem about that is it's a fork of Eclipse Memory Analyzer from 4 years ago. So any bug that's been fixed since then is not fixed in there. So I'm not trying to like destroy this project that I just created. I just think it's not perfect, but it's like if you look at the code or you look at Memory Analyzer's code, it's terrible. So I'm just glad that I have this and I can use it. And if someone feels like rewriting a heap dump, a heap parser, go for it. I'll use it. Just do it, please. Go. All right. So we have this thing that can basically do what Eclipse does. So all we need to do is call a few methods and basically the same that we did in the UI. So ask for the shortest path to GC root. We have our heap dump and we just say, okay, give me the shortest path to GC root. And what we do is actually build and representation of that, and then we output that in Leak Canary. The very interesting part here is that so think about that. You take a heap dump, right? So your memory, I don't know, it's maybe 50 megs on Android or something. Take a heap dump. That's a representation of everything that was in memory, right? So if you're trying to reload that in the same app, then you're doubling the memory, or even more. And it's going to crash out of memory. So initially I did that, and I got out of memory errors when trying to analyze the heap dump for out of memory errors. I was like, it doesn't really work. So the fix consisted in just forking in a separate process. So it's basically a service. So, on Android services, you can set the process to be different. And that means you get a fresh memory, and you can do everything you want, and it's usually enough most of the time. So then you find a problem or not, and you get a call back. And so what we did is we have a Slack channel where we upload all these things. Really, that's a hack. Someone should build a server for this. Hint, hint. I don't want to build a server right now. But the interesting part is, and you get this like sort of leak traces that tell you what's leaking and how. And we built also a nice UI. I didn't want to do that initially, but Jesse Wilson told me, you need to do that because we want this to be like a, one-liner. You just drop it in, and then you get everything that's fancy. And I think he was right. It actually makes it so much easier to use. And then if you want to get serious, you can build a server, you can upload and everything. But at the very least, you have like one line in your Gradle, one line in your application class, and you're good to go. And you're looking out for some amount of memory leaks. A nice thing to know is that because it's analyzing all the memory, it's actually able to identify the amount of memory that would have been cleared, like here 4 megs, if you had killed that memory leak. So that's very interesting to help you choose what to fix first, So we applied that to our app, and we had 94% fewer crashes from out-of-memory errors, which I think was really great. We were super excited about that. And we open sourced the project, and we got a bunch of tweets, and I really want to say thank you to the community because the response has been amazing. It's also a lot of pressure to all of these issues and professional habit, I guess. GitHub issues to fix. So really, it's been great. Now, one interesting thing I wanted to point out, this is a dev tool, right? We are taking a heap dump, doing parsing of it, and then sending it somewhere, showing a notification. You obviously don't want to show Leak Canary notification to your users, right? And you don't want to ship all of that thing in production. And it's great to detect memory leaks early. The problem, though, is there are still some memory leaks that you won't detect because you're not testing all use cases, and you'll still get out-of-memory errors in production, and we are still getting those. And so we haven't done anything yet, but basically I want to talk about the future of the Canary and where I want to play with things. The idea that I have is that we could do some sort of a complement that would help us identify the problem in the field. So you probably know about Crashlytics and how it collects information and sends that to a server where it groups things and show you everything. And I think we could do something similar with Leak Canary. So, and maybe I'm crazy, I haven't tried yet. I still need to find the time to write this, but we'll see if that works or not. The idea is that we could define our own exception handler. So when the app is about to crash, we check the exception and then we're like, okay, is it an out-of-memory error? Yes. All right, let's take a heap dump. Let's store it on the file system and then do the whole thing that Leak Canary is doing, except for the last part. So we can analyze the memory in a separate process. In the meantime, we show the crash dialog. The user is going to say, okay, kill the app, but that's a separate process, so everything's going to be fine. It can analyze in the background. We don't want to upload 70 megs to some server. Everybody would, I'm not going to say Facebook again, I guess they just did. However, what's interesting is what we could do here is we could actually do more analysis and then send the result of that analysis, pretty much like we get stack traces. We could have, okay, in its out-of-memory errors, I don't know, 40% was due to this, which is caused by this memory leak. And if we did that, then it could help solve the remaining leaks that we have in our apps. No promise here, but someday I think I'll try to do that, or if you want to do it, go for it. That's about it. Questions, again, I shouldn't have a question here. We're going to be around with Jake and you can ask questions. And there's a great quote from Benjamin Franklin, which is, "A small leak will sink a great ship." I think this is awesome. I didn't know that quote. I just looked for like, I searched Google for like memory leak quotes, and I just I was like, perfect. Yeah. So my Twitter is @py, and if you wanna, pay me a beer, you can cash me shit. That's it.